Hey there, science fans. When we talk to computers, we can't use English, Spanish, or any human language. Nope. Computers have their own special language, and it's called binary code. Think of it like this. Imagine a light switch. It's either on or off, right? That's how binary works. It uses only two digits, 0 and 1. Each 0 and 1 is called a bit, like a tiny piece of information. These bits combine to make words and instructions that computers understand. Everything you see on this screen, every game you play, every video you watch, it all boils down to these simple zeros and ones. Pretty cool, huh? Now, you might be thinking, wow, that sounds complicated. And you're not wrong. Writing directly in binary code would be like trying to build a skyscraper with just your bare hands. It's possible, but it would take forever and be super difficult. That's where high-level programming languages come in to save the day. Let's dive a bit deeper into the world of machine code. This is the language computers actually understand. The raw zeros and ones, every single instruction a computer follows is in machine code. Want the computer to add two numbers? That's a sequence of zeros and ones. Want it to display something on the screen? Another different sequence. Each instruction has to be precise and in the right order, like following a very detailed recipe. Imagine trying to write an entire program, like a video game, using only zeros and ones. It would be a nightmare. Programmers back in the early days had to do this, and it was incredibly time-consuming and error-prone. Thankfully, we've come a long way since then. We now have high-level programming languages that make life much easier for programmers. High-level programming languages are like translators for humans who want to talk to computers. Instead of using zeros and ones, these languages use words and symbols that are much easier for us humans to understand. Think of languages like Python or Java. They use English words like print to display something on the screen, or if and else to make decisions. This makes writing code much faster and less prone to errors. Imagine trying to learn a foreign language where every word was just a random combination of beeps and boops. Pretty tough, right? That's what it's like for humans trying to understand machine code, but with high-level languages, we can talk to computers in a way that feels more natural and intuitive. Section 4, translators, compilers, and interpreters. Now, you might be wondering, if computers only understand machine code, how do they understand these high-level languages? Well, that's where compilers and interpreters come in. They're like the magical translators of the computer world. A compiler takes the entire high-level code you've written and translates it all at once into machine code that the computer can understand. It's like translating a whole book into a different language before you can read it. An interpreter, on the other hand, translates the code line by line as the computer runs it. It's like having a friend translate a conversation for you in real time. Both compilers and interpreters have their own pros and cons, but they both serve the same purpose: to bridge the gap between human-readable code and machine-executable instructions. Section 5. Why high-level languages matter. High-level languages have revolutionized the world of computing. They've made programming accessible to a much wider audience, not just hardcore computer scientists. Now, anyone with a bit of curiosity and dedication can learn to code and build amazing things. Because these languages are closer to how we think, writing, testing, and fixing code becomes much faster and easier. We can create complex programs, games, and applications with less effort and in a shorter amount of time. So the next time you open your favorite app or play a cool new video game, remember the amazing power of high-level languages and the role they play in making our digital world possible. And hey, maybe you'll even be inspired to learn one yourself.